Okay, so the next question that we have is find the distance of the point of some point from some line. So let me basically get rid of these over here, and then we will find the distance of the point from the line. So we have a point over here which is -1, 1, which is -1, 1, -1, 1, and you want to find the distance of this point from the line so the distance from the line 12 times x plus 6 is equal to 5 times y minus 2. Okay, so let's go over the formula that we had for, basically we had two formulas there. Let's write them down. I want to make a screenshot of these two formulas, and then we will continue with this. So that's the perpendicular distance d of a line from the point x1, y1 is given by this. So basically, if you have a line ax plus by plus c is equal to 0, and if you have a point over there as x1, y1, the distance of this, basically between this line and this point, is going to be equal to d is equal to basically the absolute value of ax1 plus b times y1 plus c over the square root of a squared plus b squared. So this is the distance of a point from a line, and then we had also something else called the distance of two parallel lines. The distance of two parallel lines. So the distance, we have the distance of two parallel lines, which is given by if you have basically two lines, y is equal to mx plus c1, and if you have basically y is equal to mx plus c2, then the distance between these two lines is given by the absolute value of c1 minus c2 over the square root of 1 plus m squared. That is if the lines are written in this way. Now, if the lines are basically written in this manner as basically as ax plus by plus c1 is equal to 0, and ax plus by plus c2 is equal to 0, then the distance between these two lines is going to be d is equal to basically the absolute value of c1, and this is, as you can see, this is capital C coming from here, c1 minus c2, the absolute value of that, over the square root of a squared plus b squared. And that's basically the whole story there. So now what I'm going to do is that I'm going to make a screenshot here, and then we will go back to the example and solve the problem. Okay, so I'm going to save this somewhere on desktop. Okay, so now what we have is that we want to find the distance of the distance of this point from this line. So now first you need to basically somehow simplify this equation and write it in either in slope-intercept form or in general form. And then based on that you can find one of the formulas, meaning that you can write this as 12x plus 72 is equal to 5y minus 10. So you can write 12x minus 5y and plus 82 is equal to 0. So 12x minus 5y, and here you have 72 plus 10 is equal to 82 is equal to 0. So this equation of the line, since this is in general form, I'm going to basically pick the general form of the I'm sorry, I made a mistake. I'm going to basically the distance formula that we have for a line and a point is basically d is equal to the absolute value of ax1 plus b times y1 plus c over the square root of a squared plus b squared. Square root of a squared plus b squared. So these two numbers over here, your x1, y1 come from here, and abc come from your line, meaning that your a is equal to 12, your b is equal to -5, and your c is equal to 82. So based on this, you can write your d is equal to basically the absolute value of a, which is equal to 12 times x1, which is -1, plus b, which is -5 times y1, which is equal to 1, plus c, which is basically 82, plus 82, and then you need to divide that by the square root of a squared plus b squared. So that's 12 squared plus -5 whole squared, and that is equal to basically the absolute value of -12, -5 plus 82 over the square root of basically 144 plus 25 is equal to 169, and that is equal to, of course, 13. Now this is 17. 82 minus 17 is equal to 7, 12, 5 and 6, 65. So that is 65 over 13, and 65 over 13 is equal to 5 times 2 is equal to 15, 1. So that is a 5. So the distance between the perpendicular distance between this point and this line is therefore 5 units. Is therefore 5 units. So that was question number 4. 5 units. So question number 5. That was question number 4. Now question number 5. Question number 5 is find the points on the x-axis whose distances from this line are 4 units. We want to find the points. Find the points on the x-axis. On the x-axis whose distances from basically this line, which is equal to x divided by 3 plus y divided by 4 is equal to 1 are 4 units. So basically you want to know how many points you can find on the x-axis whose distances from this line are basically 4 units, and this line is basically is supposed to be this line over here. So 1, 2, 3, and 4, and this is supposed to be your line. So this is x and y, and this line over here is x divided by 3 plus y divided by 4 is equal to 1. And if I simplify this, I will get basically multiply by 12. I'll get 12 divided by 4 is equal to 3x plus 4. I will get basically 12x divided by 3 plus 12y divided by 4 is equal to 12. That's 4x plus 3y is equal to 12, and that's 3y is equal to negative 4x. 3y is equal to negative 4x plus 12, and so divide by 3, you'll get y is equal to negative 4/3 x plus 4. So your y-intercept is equal to 4, which is correct, and your basically your slope is negative 4/3. First of all, it's negative, and for 3 units of horizontal change, you have negative 4 units of vertical change, which is basically your slope over here. As you can see, negative 4 units of vertical change, 3 units of horizontal change. It's exactly this line. And as you can see, basically the x and y intercepts of a line is nothing but basically it's ultimately it's just a ratio, meaning that even if the line is basically way away from the axis, it's going to give you a ratio, basically how many units you, meaning that when you have a line up here, if you have for example a line like this, let's say that you have a line like this. So as you can see, the rise over the run, this is the slope of your line, meaning that this over here, if I call it h, and this thing over here, if I call it k, then of course h over k is basically is the slope of your line, slope of the line. And you see the ratio is of course would of course be much larger than if I basically, for example, drew this line. You see, for example, over here, this ratio of h to k is nearly 1, meaning that this distance is nearly the same as this distance. But this distance is nearly twice as this distance, so the slope of the line is twice the slope of this line, this orange line over here. So basically, the x and y intercept of a line and the ratio of the two is just nothing but the slope of your line, and it's something that I had never actually realized before. Okay, so that is that. Now, what I want to do over here, of course, I just keep talking about different things, but I suppose they are interesting things, and while you're basically working on mathematics, you run into this, you run into that, and if you have enough patience to pay a little attention to this, a little attention to that whenever it's interesting or necessary, then of course you will learn a great deal about mathematics in a short amount of time. Meaning that, for example, the ratio of the fact that the ratio of the y-intercept of a line to the x-intercept of a line is actually nothing but the slope of the line, you would probably never find this piece of information in any mathematics books you might ever read. But it's actually a very interesting piece of information or fact, you could say, that you can find on your own while you're just really playing with mathematics, really. Okay, so I take a few minutes rest and we will continue with the rest of this, and I don't really know where I was, but we'll find our way through this. Okay, so the next question that we have here is an interesting question. Let me create a new layer here, 242, and the question is, find the points on the x-axis. It says, the question asks, find the points on the x-axis whose distances from the line from the line x divided by 3 plus y divided by 4 is equal to 1 are 4 units. So basically, the line that you have, of course I did talk about this example a little bit, but then I had to stop for a long while, and so I have to start over. So let's suppose that, for example, you have this line over here. Basically, about this line, you know that the x-intercept over here is 3. The x-intercept over here is 3, and the y-intercept is 4. And technically, we say that this line is in the intercept mode. I'm sorry, in the intercept form, meaning that both of the intercepts are readily available to you in the equation. So if the x-intercept is 3, you get 1, 2, 3 over here, and 1, 2, 3, 4 over here, and if you connect these 2 points together, you will get the equation, the graph of the line. and this is y, and this is x. Now you want to find all the points on the x-axis whose distances from this line, and distance means perpendicular distance from this line, are basically is 4 units. So the distance, we talked about the formula that gave us the distance between a point, that gave us the distance between a point x1 comma y1 and the line ax plus by plus c is equal to 0. And the formula was basically d is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. This was the formula, if I'm not mistaken. I don't know if this one over here. Okay, so it was basically ax1 plus by1 plus c over the square root of a squared plus b squared. So in this formula, I need a point x1, y1 and a line in this format. So I take my line over here, write that x divided by 3 plus y divided by 4 is equal to 1. And then since I want to have it in this form, I multiply the line by 12. So I get 12x by 3 plus 12y by 4 is equal to 12. And that means that 4x plus 3y is equal to 12. And so then I will bring this to the other side of the equation. That means that 4x plus 3y minus 12 is equal to 0. So that is the equation of the line in the general form. And now I have my A, I have my B, and I have my C over here. So then I can write and since the point is on the x-axis, this point is supposed to be on the x-axis, the y-intercept of that point is 0. So this point becomes x1 comma 0. x1 comma 0. So I write d, which is equal to 4 units. 4 is equal to the absolute value of a times x1. So over here a is equal to 4. 4 times x1 plus basically b times y1. B is equal to 3 over here. B times y1 is equal to 0 plus c, and my c over here is equal to negative 12. The absolute value of this over the square root of a squared, which is equal to 4 squared, plus b squared. B squared is equal to 9, or 3 squared, which is equal to 9. So I can write this as the absolute value of 4x1, this is 0 minus 12, divided by 4 squared, which is 16, plus 9 is equal to 25. The square root of 25 is equal to 5. So that means that basically 4 times 5, which is equal to 20, is equal to the absolute value of 4x1 plus minus 12. Now, since this is an absolute value equation, you need to find it properly. Otherwise, you will not get the right answer, or you will get only probably one answer, or anyway, the answer will not be appropriate to this situation. And what this means, what this absolute value equation actually means. The absolute value is basically a way to one of the things that you can do with the absolute value function, or one of the ways that you can that you can think about the absolute value function, is basically distances. Meaning that if you imagine that you have a for example, not a real number line, but a number line on which the integers are identified. So you have 0, for example, 1, 2. Of course, the real numbers can also be identified here, but for the sake of this example, the integers will actually suffice. The real numbers would be a little bit complicated for this example. So 3 and so on and so forth, 1, 2, negative 1, negative 2, negative 3, and so on and so forth. So now over here, if I say that, for example, the absolute value of 2, if for example, if I say that the absolute value of x is equal to 2, this number which is outside the absolute value function, this denotes a distance, and this number, wherever you meet an absolute value function, this number that is outside is always positive. It's not possible. It's actually not really possible to write, for example, the absolute value of x is equal to negative 3. This is actually wrong. This cannot exist. So this number is always positive based on the nature of the absolute value function. And what this means is that x is a point on this number line whose distance from the origin, or the 0 on the number line, is 2 units, meaning that x can be basically this point over here, or it could be this point over here. So then basically you can say that x is equal to plus or minus 2. So that's the meaning of the absolute value function. And as you can see, this distance from 0 is 2 units, and this distance from 0 is also 2 units, irrespective of the sign. The distance is 2 units. So we say that the absolute value of x is equal to 2. That means that x is either positive 2 or negative 2. Now what is hidden inside this expression that you might not see right now is that what this means is that basically what I have actually written is that what I have really written is x minus 0 is equal to 2, meaning that the distance between this number x and 0 over here is 2 units. So now instead of this 0, I can really use any number or any expression, meaning that I can write, for example, the absolute value of, for example, x minus 4 is equal to 2. That means that x is a point such that the distance of that point from positive 4 is 2 units. Meaning that if this is 4, 5, and 6, then the distance of this point x from positive 4 is 2 units. So you would get either 6 or 2, meaning that this distance is 2 units, and this distance over here is also the same 2 units. So there you can say that x is either 2 or x is equal to 6. Now in order to be able to systematically solve this equation, what you will write over here is that you will write basically x minus 4 is equal to plus or minus 2. Now if x minus 4 is equal to 2, then that means that x is equal to 6, and if x minus 4 is equal to negative 2, that means that x is equal to basically positive 4 minus 2, which is equal to 2. And basically these are the two answers that I got here. So that is basically the meaning of the absolute value function. Wherever you basically come across absolute value function, you have to basically make sense of the absolute value function this way, based on this example. And of course there are many other types of equations that you can write, meaning that you can even, for example, use inequalities or things like that. Meaning that, for example, you can write, for example, the absolute value of x minus 2 is greater than or equal to, for example, 5. Is greater than or equal to 5. And in that case, then you can use the same logic to solve this equation. But I'm not going to get into that because it's really not necessary right now. So now, based on this, what I'm going to do is that I'm going to write this as basically 4 times x1 minus 12 is equal to plus or minus 20. That means that 4 times x1 minus 12 is equal to 20, or 4 times x1 minus 12 is equal to minus negative 20. In this case, you have 4 times x1 is equal to basically 32, which means that x1 is equal to 8, or you can say basically 4 times x1 is equal to negative 8, which means that x1 is equal to negative 2. Which means that x1 is equal to negative 2. So this is your solution set. Either x1 is equal to 8 or x1 is equal to negative 2. Now, so I'll get 2 points over here, negative 8, and I get positive 8 and negative 2. So x1 is equal to 8 or basically negative 2. That means that I will get 2 such points over here. I'll get basically 8, 0 and negative 2, 0. And as you can see, if I find this point over here, it would be basically this point over here. This is negative 2, 0, and this point, the perpendicular distance of this point from this line is going to be 1, 2, 3, and 4 units. Well, approximately, of course, my basically units are not all to scale, but you get the idea. So this distance over here is 4 units. And also if you go for 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 0, you see that the perpendicular distance of this point from this line is 1, 2, 3, and 4 units. This is also 4 units. So you get 2 points over here, 8, 0, negative 2, 0. In both cases, the perpendicular distance of the point from this line is basically 4 units. So that's basically that's basically the, I mean, how mathematics is both beautiful and organized and systematic, and well, I mean, there is it's just a beautiful system, really. Just a beautiful system. Okay, so the next question that we have is question number 6, which is find the distance between parallel lines. So we have a couple of parallel lines. For example, you have 15x plus 8y, 15x plus 8y minus 34 is equal to 0, and 15x plus 8y plus 31 is equal to 0. These two lines are parallel, as you can see. Basically A1 to A2 is the same as B1 to B2. Of course, it's not equal to C1 to C2. If basically you got basically something like this, A1 to A2 is equal to B1 to B2 is equal to C1 to C2. If these ratios are all the same, then you would essentially get two identical equations, meaning that, for example, you could have, 2x plus 3y plus 6 is equal to, for example, 0, and I just simply multiply this equation by 2. So 4x plus 6y plus 12 is equal to 0. So now you can see that 2 to 4 is equal to 3 to 6 is equal to 6 to 12. This is 1 to 2, this is 1 to 2, this is 1 to 2. These are all equal to 1 to 2. And in such cases, basically, the two equations are actually the same equations, meaning that if you divide every term in this equation by 2, you would get the same equation over here. So they are basically a case of basically parallel lines in which the lines are exactly on top of one another. But if you have this situation over here, you would get a pair of parallel lines like this. So that's basically that. Now, so now you want to find the distance between these 2 points. I need to take care of my coffee. Okay, so now in order to find the distance between these 2 lines, we had a formula which was basically this thing over here. So if you have 2 lines in this form, in this general form, meaning, for example, ax plus by plus c is equal to 0, and that is c1, and that is ax plus by plus c2 is equal to 0. And over here, as you can see, this part of the equation, basically these parts are exactly identical because the lines are, of course, parallel. These are parallel lines. So if you have these 2 lines, then you can write the perpendicular distance between the 2 lines as the absolute value of c1 minus c2 over the square root of a squared plus b squared over the square root of a squared plus b squared. So having this in mind, you can come over here and write the distance of these 2 lines as basically the absolute value of c1 minus c2. So I take this as c1 and this c2, so negative 34 minus 31 divided by the square root of, you can a and b, you can take any of these, they are both a and b, that doesn't make any difference. So that's 15 squared plus 8 squared, which is equal to 64. And so this is equal to basically 65. So that's negative 65, the absolute value of that, negative 65. And 15 squared is equal to 225. Just to make sure, 5, 2, and 75, 0, 15, and that's 5, 12, 225. So this is 225 and this is 64. So that's a 9, that's a 8, 289. So this is the square root of 289, and the square root of 289 is equal to 17. I think so. The square root of 289 is equal to 17. So this is equal to 17, and then you have basically 65. Is the absolute value of negative 65 is positive 65 by 17. And that's the same thing as well, 65, divide that by 5, you will get 5 times 65 divided by 5 is equal to, I suppose, 15 or so. So 1 times 5 is equal to 5, 15, 13. So 5 times 13. So you cannot simplify this really. So the distance between these two lines is 65/17 units, which is hopefully the right answer. Number 6, 65/17 is the right answer. The second part of this question is we have another two lines. Which are L times x plus y plus p, L times x plus y plus p is equal to 0, and L times x plus y minus r is equal to 0. And so these lines, you need to kind of write them in the general form, meaning that you can write this line, call this 1, call this 2. Number 1 gives me basically Lx plus Ly plus p is equal to 0. So these are my, that means that basically your a and b are equal. And then 2 gives me basically Lx plus Ly minus r is equal to 0. So of course the c's are different. So then again I can write d is equal to basically the absolute value of c1 minus c2 over the square root of a squared plus b squared, and that gives me basically the absolute value of c1 minus c2. So p minus negative r, which is p plus r, and the absolute value of L squared plus L squared, which is equal to 2 times L squared. And so you would get, depending on whether L is positive or negative, But depending on L were positive or negative, you would have to write this as the basically plus or minus L if you take your L out. But I'm not really going to do that. I'm just going to leave it as it is because I don't have any conditions on these variables here. I don't really know what's going on. So I'm going to write it as d is equal to basically this thing over here. And then if you knew more about this situation, of course you would be able to decide how to simplify this. Otherwise, this way I would have to write a whole lot of things on here, meaning that for example I could write this as, for example, P plus R over you see, the trouble over here is that, for example, when you have the square root of 2L squared, and if you want to, that is the same thing as square root of 2 times the square root of L squared. Now, if this is, now suppose that, for example, suppose that you have the square root of 9, for example. You have the square root of 9. If you're dealing with the principal square root function, this would be equal to 3. But if you were dealing with the simple the square root function that deals with also negative numbers as an argument here, then the square root of 9 could give you plus or minus 3. And the reason for that is that basically plus 3 whole squared is equal to 9, and also negative 3 whole squared is equal to 9. And both of these numbers are 9, and this is a 9. So there is no way to know what's going on here. Unless you basically had some information about the square root function or the situation or something like that. So over here again, L squared, it could give me, depending on, well, I mean, just very much to simplify the situation, I would say, depending on the nature of the square root function, it could give me either an L. This would give me either an L or it would give me basically plus or minus L. So there is no way to know what to do here. But suppose that, for example, you're dealing with this problem in the context of a physics problem, for example. Now, in the physics problem, for example, you're dealing with a bunch of forces and a bunch of distances and a bunch of constants and so on and so forth. So in that context, you would know what this was. You would know what, for example, L represented. If you knew what L represented, then you would be able to simplify it. Then you would basically, based on that context, you would basically decide that I'm going to write this as plus or minus L, or I'm going to write this as just simply L. But over here, since you don't have any information really about this situation, this is just an abstract situation, there is no way to know what to do, right? And so I'm going to just leave this thing as it is and not confuse you unnecessarily. When we get into physics, which is hopefully soon, then over there we know what to do with it in these situations. Otherwise, this is abstract mathematics, and so we have to do things in an abstract way, of course. So now let me see if my answer was right. Number 6 is 1 over square root of 2 . Okay, so they have written this as what they have done. They have simplified this as basically you can, of course, you have to keep p plus r in the absolute value function, and then basically this thing over here you can write it as basically square root of 2l squared. You can write it as the square root of 2 times the square root of l squared. And well, if I assume that this is supposed to be equal to only l basically and not negative l, so if I suppose that basically the square root of l squared in this situation is supposed to be equal to l, then basically I'm going to basically write this as the I'm going to write this as basically the square root of l squared. I'm going to write it as the absolute value of l. The absolute value of l. And the reason why I'm using the absolute value function is that basically l well might be a negative number. If it's a negative number, I don't really know what they have thought. I mean, what sort of logic they have used to simplify this equation. But at the end of the day, when you don't have enough information, you simply cannot decide what to do with such basically equations. So, but at any rate, what they have done is that they have written the square root of 2 times l squared. You can write it as square root of 2 times the square root of l squared, and so they have written this as the absolute value of l, and then over here the square root of 2. And so they have written this as 1 over square root of 2 times p plus r over n, and then they have used the absolute value function around the whole thing. So that's the kind of answer that they have provided here. But well, again, this really doesn't mean anything. Does not mean anything as long as you don't know what's going on in this situation, and there is no situation here, so it doesn't really matter what you do with this situation, what you do with this equation. You can just leave it as it is, and then just go about your own business. That's basically what you do in such situations. Okay, so the next question that we have is question number 7. Find the equation of the line parallel to the line and passing through the point this. Okay, so I'm going to end this video here, and in the next video we will continue from question number 7. I'll see you in the next video.